Okay, this is dedicated to the major groups on the periodic table. The very first one, I did discuss this in the last video. I'm going to discuss it again. Hydrogen is a group itself. It has a +1 charge. It has one valence electron. It is a diatomic. There are 7 of these on the periodic table. Basically, they're the girls on the periodic table. They can't go anywhere by themselves. They have to be with their girls, going to the restroom, or they could be walking the halls with their boyfriend. Okay? So they are never by themselves. Hydrogen's one of these. You need to make sure you mark that. There are 7 of them, and I'll discuss that a little bit later. Hydrogen kind of acts like group 1, but kind of doesn't. It's a gas. The rest of group 1 is going to be a solid metal. Hydrogen obviously is a non-metal. So there's lots of differences there, but again, what bonds it there is because it has +1 charge. I gave an example reaction. We did this. We did the decomposition of water. So here I have water plus 2H2 plus O2. I've went ahead and balanced this because you are coming around the point. We will be soon doing balanced equations, so I'm trying to get it in your head what these look like. And this is a decomposition reaction because the water broke down into its components. You should have already done this for homework. You're supposed to color up your periodic table, so that should already be done. Now, alkali metals, they have a +1 charge. They have one valence electron. If you see me write VE, that's referring to the valence electrons. These are highly reactive. You put a little piece in water, and depending on which elements you have, it reacts violently. Lithium, not so much, but when you get down to the other elements, they get a lot more violent in the water. So that is a major thing that makes them different. And the reason that those are very reactive is because they have that one valence electron. It's easier to lose 1 electron than gain 7. So they're very happy with losing that 1 electron to gain stability. Alkaline earth metals. I'm not going to lie to you. You're going to get alkaline metals and alkaline earth metals confused. Alkaline earth are 2 words, so it's group 2. They have a +2 charge. They have 2 valence electrons and the outside shell. They're not as reactive as group 1 because they have that additional electron. It's a little bit harder to get rid of the second electron, but they will lose 2 electrons. So their reactivity is not as impressive as group 1. Okay, the boron family. The boron family is kind of boring. It's really a mix of people. You've got metals and metalloids and nonmetals mixed all in here. The only thing really bonds them together is they have a +3 charge due to their 3 valence electrons. The carbon family. We love the carbon family. There's a lot of things that carbon can do. It has 4 valence electrons. Carbon is a backbone of a lot of components in our own bodies. Sugar is made of carbon. We are a carbon-based constituent. I have ±4 because there's really not a charge associated with it because it's in the middle. It's going to share its electrons. It's a happy person and likes making people happy. One thing I did put up here was the bike because carbon has been used with carbon fibers to make bikes even lighter. Silicon and germanium are important in this group. They are important semiconductors, so computer industry really looks at this. Nitrogen family. Nitrogen makes up most of your atmosphere. They have 5 valence electrons. They have a -3 charge. They're also important for our neuron receptors. You learned that in biology. In order for your synapses to work, you have to have nitrogen present in order because that's based on electricity. Okay? Okay. Enough said on that. Oxygen family has 6 valence electrons, has a -2 charge. This is a historical thing. During the 1980s, they made a lot of stuff with CFC, sorry, and it was a carbon fluorochlorine atom. And the problem was when it went up into the atmosphere, it interfered with ozone. You should know what ozone is. Ozone is O3. Okay, this is a common question. It's a rare form of oxygen. It's a very important form of oxygen because it blocks UV light. And so the problem was this chlorofluorocarbon atom would come in there and knock off one of the oxygens. When you knock off one of the oxygens, you can't necessarily get it to bond back on there very easily. So our ozone layer, which is responsible for keeping the ultraviolet light out, was being destroyed, as they believed. This was a theory. We believe we have proven it with the data. And because we lost our ozone, we lost our protection against ultraviolet light. Okay? And just a note here, because we are dealing with mustard right now with our lab, many things that stink contain sulfur, which is that rotten egg smell, which is also in this family. Halogens. Halogens have 7 valence electrons. They have a -1 charge. Because they only need 1 valence electron, they are very active, and they will get what they need. Another curious thing about this group, which is really interesting, is that as I go down the group, my colors change of the gas. So fluorine is like a pale yellow. Chlorine is more like a pale green. Bromine is kind of like an orange brown. And then iodine, you should have seen iodine, it's a purple color. And then acetane is more like a black purple. So it's an interesting occurrence you see with this family. Noble gases. Noble gases are important. They have 8 valence electrons except for helium. Helium only has 2, but it's still a full octet, a full shell for that. It has a 0 charge. It's inert. They're noble gases. They're not reactive. That's really all I got to say about them. And you need to know them because they are the ones everybody wants to be like. They want to be like the noble gases and have all the electrons that they need so they can all be happy. And transition metals, at this point, what we're going to say is they have various charges. It's a curious family. They have wide uses and properties. We're going to see a few patterns emerge, but there's a few differences too. Intertransition metals are similar to transition metals. Some are radioactive. We know some famous ones like uranium and the atomic bomb. They're slightly different from the transition metals, but have similar types of properties. Diatomics. I can't express enough how much you need to know these. There are 7 on the periodic table, and I'm encouraging to mark your periodic table up. They form a 7. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. Hydrogen's the only one that's not present in that 7. Mark these up on your periodic table. Don't lose them because you're going to need them when you go balancing equations. Okay, so your assignment is you're going to compile a list of properties for each major group on the periodic table. Groups 1 through 8 and their names. Yes, some of them have names. Transition metals, intertransition metals. You need more than what I have given you here. Okay? Don't make a long list. Don't make it for an encyclopedia. Make it kind of brief. You're welcome to type these up and print these off, but you're going to need to know these. You're welcome to look through my notes as well, and you're welcome to look at some of the videos I've put online for you. Okay, have a great day.